My name is Lucas, and I'm going to talk today about better UIs with state machines. First of all, I'm Lucas Reis. I'm a senior front engineer here at ZocDoc. This is my Twitter handle. So yeah, follow me, I'll follow you back, this kind, yeah. All right, first question of the night is, did you go from infinite planning to no planning at all? So back in the day, most of you are very young. You didn't see that day where we had, like, I don't know, months of planning, giant specs, and life was really miserable at that time. Today, we're like agile in an agile world. We are super like fast and iterating, and now a lot of our projects have no planning at all. So, oh, this is what I need to do. Yeah, let me start coding because, boom, agile. So my claim is we're getting too far to the other side of the panel. We are losing a lot by not planning. Planning is okay. And the first question I get when I say that is people are like, what? Are you bringing back waterfall? So waterfall was what was happening back in the day. And I'll just say, no, it's not waterfall. I'm only claiming that we need some planning. I'm talking about like 2 hours of planning instead of 2 months. Even minutes of planning could be good, and for a really complicated like page or component, 2 days can save you weeks back in the line. So coding is more costly than planning. Writing code, changing code is more, it's going to be more costly than erasing a whiteboard, draw and then drawing again. Also, I claim that we are able to solve big problems and catch bugs with planning. Like if you look really carefully and if you are very precise in your specs, you can find a lot of problems even before coding, and this is good. And also the best part of planning is that during planning, we can leverage knowledge from people that are not coders. We can collaborate really close with the designers and the business people, and they usually know a lot about the domain, things that sometimes we as engineers, we don't know all the details, and also really smart people. We want to collaborate with them. So having that said, now that we're sold that planning is good, I'm going to say the finite state machines are a great tool for planning UIs. First of all, what are those? So here we have an example of a finite state machine, a really simple one. We have two states, off and heating. This is a model of an oven, right? So we have this 2 states. We have an initial state. That arrow over there is pointing to the initial state. We have 2 events, a bake pressed and off pressed. These events, they trigger state changes. So whenever bake's pressed, I go to the heating state. Whenever off's pressed, I go back to off. Super simple. We can make it as complicated as we want. For instance, here I'm modeling an oven that when it's too hot, it triggers the too hot event and transitions to idling. When it's too cold, it goes back to heating. And if I press off, it doesn't matter if I'm on heating or idling, I go back to off. So I can just go building the specification of my Ys with this model. So summarizing, we have a list of states, we have one initial state, a list of events that trigger transitions between those. 2 things I didn't show in those models. Transitions may be conditional. We can have guards, like only transition to that state if this condition is held. And also a state can trigger actions upon entering or exiting a state. I'll go more in details later about those. So, problems with that simple model is that our UIs are complicated and usually have a problem of state explosion. So we have like so many states that the model is not helpful anymore. So a really smart guy named Harel in 1987, he developed this state charts concept, which is, you can think of them as an expansion of the normal finite state machine model. So in this case, our oven model, you can see that we have the off and the baking state, but inside the baking, we have a substates. We have a machine state inside that state. So whenever I enter baking, then my first state is heating, too hot, too cold, blah, blah, blah. When I press off, I go back to off. This is a great tool, the substates, because we can zoom in and zoom out of our model, so we can think about the problems in a really separated way. Another, it's too small, I'm sorry, but another expansion of the state machines that state charts give us is we can have parallel machines. In this case, I have the oven and I have the oven light. So I can press light on and off independently of what's happening in the oven. And this, when you have a normal finite state machine model and you have like n different states, you end up with a combination. So this, we can avoid the combination and only think about the two machines. A third concept of state charts that we can see here is the off-pressed event that is issued by the oven also affects the oven light. So we have broadcasting. So we can, parallel machines can also react to the same events. So when my lights are on and I press off in the oven, the lights also go off. So summarizing state charts, we have hierarchy, we have parallelism, we have broadcasting. So state charts are great because they're high level enough to be able to be developed by non-coders. So people from business, people from design, they can develop a state chart together with you. And it's low level enough to actually help you with your code. So this is a great quality of state charts. It makes your specs more precise because the business and the design, they need to make it precise to be able to be a valid state chart, and your code gets more correct because you're using the same documentation for your specs in your code. Having said that, since we're on a React meetup, let's implement a React component using a state chart. Oh, are you ready? Yeah. Okay. Let's do this. First of all, I want to build, since we're in ZocDoc, let's build an insurance speaker. So imagine that the person in the website wants to choose their insurance, right? So we need to choose a carrier and we need to choose a plan. This is a really simple model of insurance. Insurance is extremely complicated. I just moved to the United States in 1 year, and it's crazy. But this is like 90% of what we need with insurance. So let's say I have already selected here a carrier. I can choose my plan. The carrier and the plan are being shown in the input. If I click, I can reset. I'm loading asynchronously this list. I can get here and choose one, green cross, green shield, loading, all right, I don't know, PPO, something. This is the insurance speaker that I'm going to implement now with state charts. First thing we do, we prototype using Sketch System. This is a great website that lets you prototype working state charts. So here I can like click open. Now I'm the carrier selection substate of open. If I click inside, I go. I want to show you really quick here. Like this is the website, and this is what produced my example there in the deck. This is really simple I can create a new state here. Let's see, I want to create a reset insurance state. You can see that the reset insurance state is created here, and I want it to react to the reset event and go back to carrier selection. So if I do it here, and I'll make my plan selection go to that, I can start here. I'm closed, I click, I go to open, select my carrier, select my plan, reset, I go back to select. Okay, so this is a great prototyping tool. There was some live encoding there, did you see? Yeah. I'll try not to do any more than that. All right. So next step, now we have a great prototype. Let's create a state chart using the XState library. XState library is a great library for managing state charts, and you have a JSON representation of your state machine. This is the JSON representation of the first oven model. So you can see you have the states, the off, the heating. So you start writing your state machine in this format, and you can see your state machine in the visualizer. It has a great tool, like I can copy this. This is the visualizer tool, XVis tool. So if I am starting to see here. So if I change names, if I change events, I can add everything. This is a new environment to work with your state chart. All right, going back. This is the resulting state chart of our simple insurance speaker. So here we have two parallel machines. We have the input is a machine, the drop-down menu is another machine, and the input is a simple machine. It's empty. If I select the carrier, it goes showing carrier. If I select the plan, showing carrier and plan. If I reset, it goes back to empty. In the drop-down, I have visibility, also with some transitions, responding to events. And I have the insurance options, which is actually the machine for the contents of the drop-down. They are here, and I even have some loading states because I'm already putting in my state chart the information that I am fetching stuff asynchronously. So this model is the exact model that I'm using in this code here. So this is being generated by that model, and I'm going to show how. So I'm going to use a library called React Automata to create the component. I already have my state chart, my JSON state chart, remember that? So before I talk about my React code, back in the oven model, what was missing there? What was missing in my oven model? It was too high level. What was missing is the actual food. There was no mention of food in the model. It's like another level. So the food is your business state. So this is going to be handled by React when we use React Automata. So in the state machine world, we call it extended state. So first thing I do if I'm creating a component with state machines is declare my extended state. So all the state that I'm going to manage with React is this one. Selected carrier, selected plan, the carriers in the plan, which is already really great because this is all the business data that I need. And this is the important data too. I don't have those crazy booleans. The lights, yeah, something happened to the lights, but okay, I'll continue. I don't have those, lights are off? Okay, all right. So I don't have those crazy booleans like is loading, is transitioning, is error. Like those booleans make your code crazy, creates a big ball of mud. Here I only have the state that we care about. So first thing I do, declare the extended state, the state that is not being used in the finite state machine. Then those actions that I triggered, like when I enter a state, they're methods in my component. Here I have fetch carriers and fetch plans. I set the state with the carriers after I get them, and then I transition, I generate the code. Transition is a function that React Automata gives you. You just say transition and put the name of the event. The machine will take care of everything for you. And also you have like a collection of components to use that render only conditional to the state you are in. So this is the code. Like if I am in the menu visibility shown state, I'm going to show what's inside. If I'm in the loading state, here there's a really cool wildcard that I can use and makes it even simpler to show what to decide what I'm going to show. And of course, in the end, hire the component, plug it in, your state chart, your component. That's the size of the component. This is the only code that I used for that component. So it's 80 lines of React code, which is, I was really surprised by how lean was my component. Going back, this let me show in the code sandbox. This is the actual code that we are using. So this is our insurance speaker that we just implemented with the reset and the click outside, everything. And this is the component that is generating that view. So we have here like just 4 methods, a render function. Here's 90 lines because I stripped the blank lines. This is everything. I have the state chart, and I have this component here. So let me go back here. It really worked well and with a lot less code than I thought it would be in this case. This is a complicated, a complex component that was made really simple. What I like about this process is that most of the time I spent in the sketch systems prototype and the X state, like doing my finite state machines. And at that point, I was collaborating with designers and with business people if I was in a real situation. So we would be leveraging everyone's knowledge to create our React components and not go into our DOM and stay there for a while and then I don't remember that part really well. Can you clarify? Or there's a new state, you need to make a new screen. For me, overall benefits of finite state machines is that preciseness of specs and correctness of code. That component works. I have no doubt it works. React Automata has even a feature that generates automatically a bunch of tests for you with all the different states and creates snapshots of those. So it's really important. In a particular React app, because finite state machines can be used with any framework, but on a React app, it leads to smaller React components. There was a lot of less noise, less unimportant states. The only state we were managing was like important business states. There were no if clauses at all, so no room for crazy errors with all those booleans. And I had a lot of design help from the tooling, from the sketch system and the X-State visualizer. So in the future, we can expect more visualization tools. We can expect more ways to integrate JS. And what I am really excited about, we will have more tools to assert correctness. So I can see there's a lot of room for people to analyze those state machines and say like, oh, you have 3 dead states, or how quickly, I can ask questions like how quickly can I get from state A to state B? How many events does it need to happen? Things like that. This will all help us with the correctness of our code. Current problems may bring unwanted complexity to super simple components. So if you have a super simple component, don't use it. It will get in your way. Another problem is lack of familiarity from devs and designers. So it's not easy. You need to dive into it. So you need to study. You need to understand like your spec really well. Some people just like jumping into familiar code. And there's still a small ecosystem. So there are not a lot of libraries yet. The ones that exist are solid, but it's always good to have great ecosystems. So that's it. Thank you very much. I also have a collection here of the most important links related to state machines, React, and JavaScript. And that's it. Any questions? The question is there a standard UML notation to build state charts? Yeah, so I'm using here the X-State library that is it seems to be becoming the standard library for state machines in the JavaScript world, and it's just a JavaScript object with a really simple documentation on the website. So yeah, you need to write it that way, but it's no UML tooling. You don't need to. So what happens when you issue an event and your state is not ready for the event? It doesn't lead to a transition. Is that the question? Okay, so you have 2 options. You can, there's an option in React Automata, if I'm not mistaken, or X-State, that you can say make it an error or not. So in real world, if you have like a hardware button in something and you don't want the button to do anything, the button will be there. You can press it and nothing's gonna happen. Like the button of your joystick when the console is like turned off. You just don't respond to it, or you can make it throw an error. All right, thank you.